Welcome to my video on the Astronomy magazine, November 1973. I want to go over and just talk a little bit about what's in here. And you see a nice picture of Orion there, Horsehead Nebula, and then the M42, Great Orion Nebula. And so I'm just going to flip through the magazine and kind of tell you a little bit about it. This is one I had when I was a teenager. The Cave Astrola, neat telescope, never had one. The lead article in this Astronomy magazine was not very old at this time. It had only been out a few months. But it talks about the redshift. This is something Hubble came up with, Edward Hubble, back in the, 40s or 50s. And it talks about nearer objects have a smaller redshift. More distant objects have a larger redshift. That's got to do with the expansion of the universe. And so this talks about different types of ways of measuring the distances to stars. So here's the Andromeda galaxy. That's the Hale Observatory photograph. And then they're focusing in on one region here, and they're looking for Cepheid variables. And that's the way they determined initially the distance to the Andromeda galaxy, was through the Cepheid variables. They have a known absolute brightness, and you can correlate the distance to that. Okay, this is going to start talking about parallax next, and parallax is, talk a little bit about that. Frederick Bessel, 1838, and made the first observation. And this goes back to the idea here. You got a baseline, which is going to be the Earth, the measuring angle, and from that, from trigonometry, you can determine how far an object is away. And so let's see, what is this? This is, I'm not sure what that is exactly. Oh, that's the Orion Nebula, it says. No, this is M33, a galaxy. It's too far away to measure parallax. And so this talks a little bit about it. And then they all start talking about this spectroscopic parallax. Basically, what you do there is you determine through spectroscopy what type of star it is, and you can correlate that to the distance depending on what type of star it is and its brightness. So spectroscopy was definitely, it's been around for 100 years by 1973. And here's a picture of what they do with the, you take a picture of the star, two sides of the Earth's orbit around the sun, measure this difference in the angle, and that way you can determine approximately how far the star away is through trigonometry. And there's other ways like redshifts, like we just saw in the first image. The greater the redshift of the galaxy, then the further away it is. And then also we can use bright galaxies to kind of get an idea of how far things are away. So these are some of the techniques they used. And here this shows if you would take the different photographs of a star at different times as it orbited as the Earth orbited the sun from different angles, you're going to see this kind of movement here. And from that, you can determine the parallax. Okay, this is the transit of the sun. In 73, November, this magazine probably came out in October, and they were going to measure the, there's going to be a transit of Mercury across the face of the sun. And these have been measured for the last few hundred years. I think one of the first ones was done by Edmund Halley, if I remember correctly. I do have a book on him if you're interested in more learning about Edmund Halley. It's on Amazon. And then this shows where in the North America you could observe during, it was observable. So transit ends before sunrise. And if you've observed Mercury, it's kind of a challenge. You really have to have a really good east or western view and know exactly when to look. I've got a video on one observation I made of Mercury a few months back, and it was kind of a pain. I had to really work at it. And so here would be a little better view of Mercury. This is one of the first ways they determined the distances through understanding the geometry of the transit of Mercury across the face. And then they did Venus, I think in 1769, that really they started nailing down the distances of the solar system. So it was a very helpful way of doing that. And the way you would observe would be usually a solar filter in place right there, the small telescope that puts a lot of energy right there, hope it doesn't break. This is probably ultimately the safest way because you're projecting the image onto a screen. You don't get quite the image. It's not as good as looking at through and then this is what I use now, typically an objective filter. That filters out all the light going in. Okay, Jewels of the Universe. So this is going to be, so what is that? Is the California student, let's see, the Trifid Nebula in Sagittarius. If you haven't seen that or got a picture of it, it's nice. It's low in the south though, so it makes it a little more of a challenge. And let's see, this is going to be the Lagoon Nebula, black and white. I think I've taken pictures of both of these and posted both of them somewhere on YouTube. They're pretty good objects to observe. I don't know, I was just looking at this, I noticed this Mayall name, Margaret Mayall. I think I met her back when I was an AVASO board member. It's been many years ago, but I think I did. And she's a real knowledgeable lady. Aries, this goes over the constellation Aries. It's one of the more humdrum constellations. There's not a lot in there. Deep sky objects, as you can see with the small telescope, it's not very prominent. You can see it's worth looking at, but it's not the most exciting constellation. Okay, this is the November night sky, the star dome where you could look. Shows the stars you would see, and 1 year was $12. That was a lot of money back in '73. I was a teenager, and I remember $12 was a lot of money. See, this is advertised in the magazine. It was fairly new then, a few months old. This goes over photography of how to use a camera. This day was 35 millimeter cameras, and we set them on a tripod and open them up through a shutter and expose it for several seconds before you got star tracking. And let's see, this is going to be Auriga. There you go, there's Capella, and there's the constellation Auriga. You can see some of the open clusters. It has several open clusters in the constellation. I've got a video on that too, if you were looking at them more closely. And they're pretty good in a telescope, a small telescope. You can see several. Cassiopeia, there's the W. And then, okay, there is the Pleiades. And this would be Taurus, Aldebaran. Okay, here's the Big Dipper. There's Mizar, that double star that you have to have good eyes to really split that. And so there's the Big Dipper pointing toward the Polaris there. A star trail in color. Most of these are in black and white because color was expensive and really couldn't do much in the dark unless you had a really nice dark room. Here's another one of Taurus and the Pleiades. And what have we got there? Don't know. Oh, Cassiopeia again. Okay, and this is Gemini right through there. And that is probably M35, that open cluster. Okay, this would be Cancer, and then you've got M44 there. And then this would be Regulus, Leo, and there's the bright star, and then there's the head of the lion. Back here's the tail, or the other end. And they're talking about Comet Kohoutek. I've got a picture of that somewhere I took back then. I need to dig that up. But that was going to be a big comet of the century. It turned out to be fairly bright, not as bright as they hoped, but it was studied quite a bit. So it turned out to be, I won't say the comet of the century, but it was a pretty good comet. It was definitely observable. The small telescope, I think it was the naked eye object even for a while. And this would be Canis Major. There's Sirius, brightest star in the sky. And I believe that's M4, if I remember correctly. It's an open cluster, pretty bright open cluster in the middle of the constellation. And here's the base of the dog. So that's the dog star. Astromarth, this is how we used to buy and sell used equipment. I've used that myself. And then Pioneer 10 near Jupiter. Pioneer 10 was launched back in '72, and that's one they sent out, which is already outside of our solar system now. And but it was just reaching Jupiter then. It had just gone through the asteroid belt and determined there wasn't quite as many asteroids as they were thinking. And you can see this, probably spilled something on this over the years. I've hauled this thing around for, well, since '73. Oh yeah, Skylab plans, Comet. There were a lot of plans for Comet Kohoutek. That was the earlier, was it 1913, I think, of Halley's Comet, I think around that time. And have extraterrestrials influence life on Earth? That's a good question. Okay, the decade of the quandary meets quasar, 10th anniversary. So this is about 10 years after they discovered quasars, very bright objects, quasi-stellar objects, very distant, very bright. Still a little debate on exactly what those are. And here's another finding from Pioneer 10, the asteroid belt less dense than thought. And then here the Soviets are getting more into space. And look at Europa, that is one of the largest moons of Jupiter, the Galilean moons. And then speaking of Jupiter, here's a neat little photograph of Jupiter. And that was probably state-of-the-art, 1973 for an amateur. And this would be the Lunar Planetary Laboratory. So this is a professional telescope. That's what you would see. And so that was good for that day in 73. We can do a little better now, definitely. A lot better. But times change. Technology improves. And so this just goes over the satellite, the 4 Galilean moons, where they are, and talks about Jupiter. And then you can see all the different, where the planets are in the night sky. This was before the internet, so you had to use a magazine like this to figure out where things are so you could look at them. And a variable star WPEG talks about how to observe that, and there's the light curve of it. It goes from about 8th magnitude down to what it looks like about 13th magnitude. And there is a finder, and these are the magnitudes so you can track the brightness of that star. And so there it is. And if you're not involved with the AVSO, it's a pretty interesting, good organization to record your variable star observations. And there's my old telescope, the old Dynascope 6. That was a good telescope. And then on the back, we've got some Celestron ads. So neat little Celestron telescopes. I've had several over the course of my life. I want to thank you for watching. I hope you got a little bit out of this little trip through an old astronomy magazine. I kind of enjoy those old magazines, looking through them and see what astronomy was like back in 73. And thank you for watching. And if you got some comments on some of these, please send them to me. I like reading your comments. Kind of tell me what your thoughts are, and I enjoy reading them. Thank you.